Hello students, my name is Professor Muhammad Asim and we are doing ADMath. ADMath for IGCSE students which have syllabus code 0606 and for CIO level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we finished exercise 9.8 and the topic of that exercise was solving trigonometric equations related to further trigonometric functions. There are, three further trigonometric functions. One is cosec, which is the reciprocal of sine. The second was the sec, which is the reciprocal of cos. And the third was cot, that is the reciprocal of tan. Today we are going to start exercise 9.9. This exercise is also related to further trigonometric functions, but this time we will not solve the equation but we will prove the identities which involve further trigonometric functions, just like we did in exercise 9.7. So let's start question number 1, exercise 9.9. Question number 1, prove each of these identities. Part A, tan x plus cot x is equals to sec x cosec x. So take left hand side and convert it into right hand side, or take right hand side and convert it into left hand side. So it is suitable to take left hand side because tan x is sin x upon cos x plus cot x is cos x upon sin x. If we take the LCM of sin x and cos x, cos cancel to cos, sin into sin is sin square x plus sin cancel to sin, cos into cos is cos square x. And you know sin square x plus cos square x is 1. So 1 upon sin x into cos x. This can also be write 1 upon cos x into 1 upon sin x. You know cos is the reciprocal of sec, therefore 1 upon cos is sec x, and sin is the reciprocal of cosec, therefore the reciprocal of sin is cosec, and 1 upon sin is cosec x. Hence it is proved left hand side is equals to right hand side. This is our requirement. So take the side where you can feel that you can easily convert it into other side. Or another guidance point is take those side, that side which have more terms. Move to part B. Part B is sin x plus cos x multiplied by cot x is equals to cosec x. Obviously we have to take left hand side because here more terms. So sin x remains sin x plus cos x remains cos x multiplied by cot x is what? Cos x upon sin x. If we take the LCM, sin x, sin into sin is sin square x, sin cancel to sin, and cos into cos is cos square x. Again sin square x plus cos square x is 1, 1 upon sin x. And the reciprocal of sin is cos x, therefore 1 upon sin x is cosec x. Hence, it is proved that left hand side is equals to right hand side. Move to part C. Part C is cosec x minus sin x is equals to cos x cot x. So take left hand side. Cosec x is 1 upon sin x minus sin x. Take LCM. Sin x, sin cancel to sin, it is 1, and sin into sin is sin square x. 1 minus sin square x is cos square x upon sin x is equals to cos square x can be right cos x into cos x, and you can write this sin x remains sin x. So cos x and cos upon sin is what? Cot x, and we achieve right hand side. So it is proved that left hand side is equals to right hand side. Take part D. What is part D? Sec x cosec x minus cot x is equals to tan x. Obviously, we have to take left hand side. So sec can be right 1 upon cos x multiplied by cosec can be right 1 upon sin x minus cot x is cos x upon sin x. 1 ones are 1, sin into cos is sin x cos x minus cos x upon sin x. Take the LCM. Sin x cos x. Sin x cos x cancelled, sin x cos x remains is 1 minus sin and sin cancel, but this cos is multiplied this cos, which is cos square x. 1 minus cos square x, sin square x upon sin x cos x is equals to this sin cancel by its square, remains is sin x upon cos x. And sin x upon cos x is what? Yes, tan x. So we achieve right hand side. Hence it is proved that left hand side is equals to right hand side. So this is question number 1. We have done all parts. Move to question number 2. Question number 2 is prove each of these identities. So take part A. 1 plus sec x multiplied by cosec x minus cot x is equals to tan x. Obviously, we will take left hand side. So 1 plus sec x is what? Cos x. Cosec is 1 upon sin x. Cot x is cos x upon sin x. Take the LCM. Cos x, cos into 1 is cos x, cos cancel by cos is 1. Take the LCM of sin x. It is 1 minus cos x. Now, you know there is a formula a plus b into a minus b is equals to a square minus b square. So 1 plus cos x, 1 minus cos x is 1 square is 1, and cos x square is cos square x upon sin x into cos x is sin x cos x. You know 1 minus cos square x is sin square x upon sin x cos x. Sin cancel to its square, and sin upon cos is 10x. And we achieve right hand side, therefore it is proved that left hand side is equals to right hand side. Move to part B. Part B is 1 plus sec x, 1 minus cos x is equals to sin x 10x. One plus sec x. We will take left hand side. 1 plus sec x. Sec x is 1 upon cos x, and 1 minus cos x. Take the LCM cos x. It is 1 plus, sorry, it is cos x plus 1 multiply by 1 minus cos x. Multiply numerator by numerator. Again we are having a situation a plus b, a minus b, which is equals to a square minus b square. Therefore 1 square is 1, and cos x square is cos square x upon cos x into 1 is cos x. 1 minus cos square x is sin square x upon cos x. This can be right sin x into sin x upon cos x. So sin x into sin upon cos is what? 10x. Hence we have achieved a right hand side. So it is proved that left hand side is equals to right hand side. Move to part C. Part C is 10 square x minus sec square x plus 2 is equals to cosec square x minus cot square x. Students, sometime when we take left hand side, we are unable to convert it into right hand side. For that type of question, we have to take both sides one by one. So first I am taking left hand side. 10 square x minus sec square x plus 2. 10 square x, you know, 1 plus 10 square x is equals to sec square x. 1 plus 10 square x is equals to sec square x. Therefore 10 square x is equals to sec square x minus 1. So in left hand side you can replace this 10 square x is sec square x minus 1 minus sec square x plus 2. This sec square x cancel by this sec square x. 2 minus 1 is what? 1. Now take right hand side. cosec square x minus cot square x. There is a formula I am writing over here. 1 plus cot square x is equals to cosec square x. So if we replace this cosec square x of right hand side in terms of 1 plus cot square x, and minus cot square x remains minus cot square x. This cancel by this and we achieve 1. Now what is the final result of left hand side? 1. What is the right hand result of right hand side? 1. So you can say left hand side is equals to right hand side. What I told you, that sometime we are unable to achieve the result. I mean, sometime when we take left hand side, we cannot convert it into a right hand side directly. But for those questions, we will take both side one by one and find the final answer. If we achieve 1 is equals to 1, then it would say that both sides are equal. Left hand side is equal to right hand side. Hope you understand. Come to part D. Part D is cot x plus tan x multiply by cot x minus tan x is equals to cosec square x minus sec square x. So taking left hand side, this is left hand side, and if you see carefully, we can apply the formula a square minus b square, because a plus b into a minus b is always equals to a square minus b square. So here a is cot, so it is cot square x minus b is tan, it is tan square x. Cot square x, cos square x upon sin square x, minus tan square x is sin square x upon cos square x. Taking LCM, sin square x cos square x, sin square x can cancel sin square x, so this cos square x multiplied by cos square x, it is cos 4x. Similarly, cos square x cancel by cos square x, so sin square x into sin square x is sin 4x. Again write this cos 4x is cos square x square, and this sin 4x is sin square x square upon sin square x cos square x. Apply the formula a square minus b square, which is equals to a minus b into a plus b upon sin square x cos square x. So cos square x minus sin square x is same upon sin square x cos square x, and this cos square x plus sin square x is 1, because this is the identity, so it is multiplied by 1. So something multiplied by 1 is something. Cos square x, and write the denominator sin square x, cos square x minus sin square x upon sin square x cos square x. This cos square cancel by this cos square. The remaining is 1 upon sin square x minus this sin square cancel by this sin square. The remaining is 1 upon cos square x, and 1 upon sin is cosec, therefore 1 upon sin square is cosec square. Similarly, 1 upon cos is sec, therefore 1 upon cosec square is sec square x. And this is what we need. Check this. This is right hand side. And we achieve this right hand side. Hence, it is proved that left hand side is equals to right hand side. Hope you completely understand. This is the whole summary of part D, a very important part of question number 2. So I hope you completely understand part D. And this is question number 2. Move to question number 3. So there are J parts in this question number 3. I will try to finish all parts in this lecture, otherwise I will finish in next lecture. Let's start part A. Prove the identities. 1 upon tan x plus cot x is equals to sin x cos x. Very easy. Take left hand side. 1 upon tan x. Tan x is what? Sin x upon cos x plus 1 upon plus cot x. Cot is what? Cos x upon sin x. Take the LCM of sin x cos x. Cos cancel to cancel, it is sin into sin is sin square x. Similarly, sin cancel to sin, so it is cos into cos is cos square x, and this one remains 1. So 1 upon sin square x plus cos square x. And this last fraction can be write in terms of division, or you can directly write sin x upon cos x is equals to this sin x cos x directly multiply by this 1. So sin x cos x multiplied by 1 is sin x cos x upon sin square x plus cos square x is 1. Hence, this is what we need on right hand side. So we achieve left hand side is equals to right hand side. So it is proved. Move to part B. Part B is sin square x plus cos square x upon cos square x is equals to sec square x. The easiest part of this question, because on left hand side sin square x plus cos square x is 1 upon cos square x. 1 upon cos is sec, so it is sec square x. Hence it is proved that left hand side is equals to right hand side. Very easy. Move to part C. Part C is sin square x cos x plus cos cube x upon sin x is equals to cot x. Again a very easy part. If we take cos is common from the numerator, so it is sin square x plus cos square x upon sin x. So cos x upon sin x multiply by sin square x plus cos square x 1, and you know cos upon sin is cot x. Hence it is proved that left hand side is equals to right hand side. Move to part D. These are very easy parts. The difference is fraction is involved. Part D, 1 minus cos square x upon sec square x minus 1. 1 minus cos square x, you know, sin square x, and sec square minus 1 is tan square x is equals to sin square x divided by tan square x. Sin square x divided by tan square x is what? Sin square x upon cos square x, or sin square x. If we convert division sign into multiplication sign, we will take the reciprocal. So this sin square x upon cos square x can be converted cos square x upon sin square x. Sin cancel, sin square x cancel by sin square x. Remaining is cos square x, and cos square x is what? 1 minus sin square x. So we achieve left hand side, right hand side, because the right hand side is 1 minus sin square x. Okay, so it is proved that left hand side is equals to right hand side. Move to part E. Part E is 1 plus tan square x upon tan x is equals to sec x cosec x. Take the left hand side, 1 plus tan square x, you know, is what? Sec square x, and tan x is sin x upon cos x. So this can be right sec square x multiply by cos x upon sin x. Sec square x can be right 1 upon cos square x into cos x upon sin x. Cos cancel to its square. 1 upon cos, you know, is sec x, and 1 upon sin, you know, is cos x. And this is our right hand side. So it is proved that left hand side is equals to right hand side. Move to part F. What is part F? Sin x upon 1 minus cos square x is equals to cos x. Easiest part, because 1 minus cos square x is sin square x. Sin x cancelled by square, 1 upon sin x, and 1 upon sin is what? Cosec x. And this is we achieve right hand side. Hence it is proved that left hand side is equals to right hand side. Move to part G. What is part G? Sin x tan square x upon 1 plus tan square x is equals to sin cube x is equals to sin cube x. Okay. Sin x and this tan square x, okay, remains tan square x. 1 plus tan square x is what? Sec square x. Okay. Sin x into tan square x is what? Sin square x upon cos square x. And this sec square x is the reciprocal of cos square x. So we can write is cos square x. This will becomes a numerator. And this cos square x cancel by this cos square x. Sin into sin square is sin cube x. And this is the right hand side. So it is proved that left hand side is equals to right hand side. Move to part H. What is part H? 1 minus sec square x upon 1 minus cosec square x is equals to tan 4x. You know, 1 plus tan square x is equals to sec square x, and 1 plus cot square x is equals to cosec square x. These two identities are very important. You must keep in your mind. So 1 minus sec square x can be right 1 plus tan square x upon 1 minus cosec square can be right 1 plus cot square x is equals to 1 minus minus plus minus 1 minus plus minus tan square x upon 1 minus plus minus 1 minus plus minus cot square x. This one cancel by this one cancel by this one, and this minus cancel by this minus. So tan square x upon what is the reciprocal of cot? Tan. And cot square reciprocal is 1 upon tan square x. And this tan square x multiplied by this tan square x, so it is tan square into tan square is tan 4x. Hence it is proved that left hand side is equals to right hand side, because we achieved right hand side. Move to part I. Part I is This time we will take right hand side because it is whole square and apply a plus b whole square formula. Tan square x plus 2 tan x sec x plus sec square x, and tan square x plus 2 tan is what? Okay, remains tan x sec x, and sec square from this formula is 1 plus tan square x. Tan square and tan square is 2 tan square x. Two tan square x and plus 2 tan x sec x plus 1. This tan square x can be write sin square x upon cos square x, and this tan x can be write as sin x upon cos x into this sec x can be write 1 upon cos x, and this plus 1 remains plus 1. So 2 sin square x upon cos square x plus 2 sin x upon cos into cos is cos square x plus 1. Taking LCM of cos square x, cos square cancel to cos square, it is 2 sin square x. Cos square is cancelled to cos square, it is 2 sin x plus cos square into 1 is cos square x. This 2 sin square x can be write sin square x plus sin square x plus 2 sin x plus cos square x upon cos square x. You know sin square x plus cos square is 1 plus sin square x plus 2 sin x upon cos square x. Now if you write in order like this, sin square x plus 2 sin x plus 1 upon cos square x. So sin square x plus 2 sin x plus 1, it is equals to a square plus 2ab plus b square. This can be write a plus b whole square upon cos square x can be write 1 minus sin square x. 1 plus sin x whole square remains 1 plus sin x whole square, and this 1 minus sin square x can be write 1 plus sin x into 1 minus sin x. This 1 plus sin x cancel by its square, and the remaining is 1 plus sin x upon 1 minus sin x. Hence it is proved that left hand side is equals to right hand side. This part is little bit lengthy but very easy, no issue. This is the summary of part I. Hope you understand. Move to last part J. What is part J? Part J is cos. Kindly wait. So part J is what? Cos x cot x upon cos x plus cot x is equals to sec x minus tan x. Very easy, taking left hand side cos x into cot x is what? Cos x upon sin x. Oh, space is short, so I am doing over here. So cos x is cos x dot cot x is cos x upon sin x upon cos x plus cot is cos x upon sin x. So cos into cos is cos square x upon sin x divided by taking LCM sin x. So sin into cos is sin x cos x. Sin cancel to sin it is cos x. This sin x cancelled directly by this sin x. Remaining work over here. So cos square x upon taking cos x from here, it is sin x plus 1. This cos cancelled by, kindly wait, we have to convert it into sec x minus cot x. So it is cos x upon 1 plus sin x, or 1 plus sin x. 1 plus sin x can be cancelled by 1 plus sin x. So it is sin x minus 1. Sin x, वही 1 plus 1 minus sin x करें तो 1 minus sin x बचेगा ऊपर और नीचे बचेगा cos x. तो यहाँ पर चाहिए tan x. Kindly wait, I am doing cos x cot x. So cos को हमने क्या किया है, cos into cos upon sin, ये हो गया cos plus cos upon sin, cos plus cos square हो गया और cos x sin x plus sin x, cos x sin x plus sin x. Kindly wait. So cos square x sin x, or sin x से कट गया तो cos square x Okay, this cos square x in the denominator can be write as or this cos cancel by this square, so remaining function is cos x upon 1 plus sin x. So this is the end of left hand side. Now right hand side is sec x minus tan x. Sec is 1 upon cos x and tan is 1 upon sin x upon cos x. Taking LCM is cos x. Oh students, I completely understand. I will do this part again. I completely understand. See this part again. Part H. Sorry, part J. Cos x cot x upon cos x plus cot x is equals to sec x minus tan x. First we have to take left hand side. Cos x, cot x is what? Cos x upon sin x upon cos x plus cot x is what? Cos x upon sin x. Cos multiplied by cos is cos square x upon sin x upon taking sin x as LCM. Sin cancelled, sin into cos is sin x cos x. Sin cancelled to sin is cos x. This sin x cancelled by this sin x, and this cos square x can be write 1 minus sin square x upon taking cos x as common, it is 1 plus sin x. 1 minus sin square x using a square minus b square is a minus b into a plus b. So a 1 minus sin x into 1 plus sin x upon cos x into 1 plus sin x. This 1 plus sin x cancelled by this 1 plus sin x. The remaining is 1 minus sin x upon cos x. Now stop. This is the last step of left hand side. Now we will take right hand side. What is right hand side of this question? It is sec x minus tan x. Sec x is what? 1 upon cos x. Tan x is what? Sin x upon cos x. Taking cos x as the LCM, cos cancelled by cos, it is 1, cos cancelled by cos, it is sin x. And you can see this left hand side last step and this right hand side last step is same. Therefore, you can say left hand side is equals to right hand side. Proved. So this is another way to prove identity. So student, this is question number 3. So many parts in this question, from part A to part J, and we have finished all parts. This is the summary of last part J. So sometime we are unable to achieve the right hand side or left hand side directly, so we have to proceed, we have to do work on right hand side as well, just like in part J. What next? Question number 4. No issue. I will do question number 4 and question number 5 very easy. Question number 6 is also very easy. So I will try to finish the whole exercise, all remaining questions, in next lecture. So this is what we have done in today's class. But if you have still any problem, kindly write in comment box. Definitely I will help you. So if you think that my videos are helping you, my videos are satisfying you, so kindly do subscribe my channel. And whenever you subscribe, don't forget to press the bell icon button so that when I upload my videos, you will get the notification. Kindly share my videos as many as you can. Okay students, good luck for next lecture.